and we're going to be having a case study of the GeoDesign Research Study in Manyatta Informal Settlements in Kisumu. My name is Evelyn Lede, and I'll be taking you through this session. In case you have any questions, use the chat section. And this webinar is being recorded and will be available in our YouTube channel. The link to our YouTube channel will also be shared on the chat section. So if you have any questions, kindly use the chat section, and our team is on standby. They will be able to respond to any questions or comments that you'll be having. So I'm going to invite my colleague planner to introduce himself. Antony, please.
Hi everyone, my name is Antony Okundi. I'm an urban planner and also a GIS consultant. So I'll be taking through the practical of how we did the geodesign. Thank you very much, and over to you, Evelyn.
Thank you very much, Antony. So today we are looking at how CityEngine can actually be used to transform urban planning and design. And the beauty with this session is that we'll actually have a case study of what has been done with ArcGIS CityEngine. So urban regional town planning is one of the main application areas of geographic information systems, and planners actually use geographic information throughout the planning process. If you think about the data collection bit, the data analysis, the design, the spatial design, all these parts of the planning process actually utilize geographic information systems. And one of the main tasks of planners is that they develop land use plans and programs that help create communities and accommodate population growth, among other purposes. So for a planner, of interest will be, especially using the ArcGIS CityEngine, creating 3D representations of existing regulatory and land use conditions. This is really, really important. And then being able to visualize and analyze the proposed changes to drive better decision making. At the end of the day, planners require a decision support system, and geographic information system provides the decision support system. And today specifically, we're going to look at ArcGIS CityEngine transforming urban planning and design. And then of course, having to present multiple planning alternatives with your team and also for the public. So for any planning process, there's need to actually include the stakeholders, the people you're actually planning for. So planning can only be done with and for the people, so that you can actually get buy-in for the plans that you are preparing. So these are really essential parts of the process that need to be considered when you're doing any plan. And with CityEngine, this is what you're able to achieve. So what is ArcGIS CityEngine? So ArcGIS CityEngine is an advanced 3D procedural software solution for creating large, interactive, and immersive urban environments. And CityEngine is actually used to model information, or actually model the real world based on real data, as we'll be looking at shortly in this presentation. And one of the main things that differentiates CityEngine from other software solutions is the procedural modeling aspect, which we will be looking at shortly as we go through this presentation. So I'm just going to take some time to explain how ArcGIS CityEngine is integrated with the other solution products that we have within the ArcGIS platform. And again, notice that we now have a branding in the name. We moved from Esri CityEngine to ArcGIS CityEngine. Not that it wasn't part of the ArcGIS platform, but the fact that we now have ArcGIS makes it more part of the platform. So in terms of integration with the other solution products that we have within the platform, we have ArcGIS Pro, which is one of the main desktop applications that we have within the ArcGIS platform. So ArcGIS Pro is mainly a general purpose application. So you can be able to get data from ArcGIS Pro and load it to CityEngine. And then, of course, we've had a lot going on about the CAD and BIM integration. This is a plus, especially for the professionals within the built environment. So it's now actually possible to bring in data sets from CAD if you're working in InfraWorks, or if you're working in Revit, or if you're working in AutoCAD and the other BIM solution products. It's actually possible to bring in that data to ArcGIS. So that makes it quite interesting. So that data can be brought into ArcGIS Pro and even to CityEngine. And then we have one of the other solution products that we have within the ArcGIS platform tailored for urban planners. That's ArcGIS Urban. So ArcGIS Urban is one of the applications that we have tailored for planners. So the difference between ArcGIS Urban and CityEngine is that CityEngine is a desktop application which is mainly tailored for design, while ArcGIS Urban is a web application. And then the beauty with all this is that we have what we are calling ArcGIS Online. So you can be able to publish the web scenes that you've created within ArcGIS CityEngine to ArcGIS Online. And this is where now, in terms of engaging the community members, if you have done your designs, then once you publish these as web scenes, then the stakeholders within the community or the area in which you're planning can actually be able to access this information. So in terms of integration within the platform, this is well integrated with the rest of the other products. And of course, with the CAD and BIM integration that we have with Autodesk. So as I mentioned, the heart of CityEngine is procedural modeling. And procedural modeling is a course-based procedure which represents series of commands. So CityEngine mainly uses what we call CGA rules. CGA is computer-generated architecture. So these are rules that are used to automatically generate 3D models. So unlike other 3D modeling solutions, CityEngine makes it very easy for you to be able to model your neighborhood, your cities, your towns, because you have rules. And the beauty with this is that CityEngine comes with a library, which we call the Esri library, that has the rules. So you can either use the rules that are already defined within the Esri library, or you can actually tailor and write your own rules. So with procedural modeling, so we have the geometry, if it's the shape, if it's the building footprints or the parcels that you have. And then the most important thing for you to have is the attribute information of the geometry that you have. So for instance, if you have land parcels, you need to have attribute information about that particular land parcel, say the land use for that particular land parcels, the building standards for that particular land parcel. Say in terms of the setbacks, how much distance are we supposed to leave, maybe the front setbacks, the side setbacks, and then again, details of the information in terms of how much you can be able to develop on that particular land parcel. Say, these are the number of floors that you can build on this particular land parcel. This is the percentage of the ground coverage that you can actually cover on that particular land parcels. So with the geometry and the attributes, then you're able to apply the rules and you're able to automatically generate your 3D models. We'll be looking at this. So in terms of the rules, so these are mainly rules usable out of the box. So you can use that, which is within the Esri library, or you can actually write your own rules. So in terms of the rules that we have rules for building footprints, we have rules for parcels and lots, we have rules for streets. So you can actually be able to generate streets and the various street furniture. And we have rules for other 3D models within CityEngine. Then again, so for you to be, you can, so as I mentioned, you can use the rules that are within the Esri library, or you can actually create your own rules. And then every version of CityEngine comes with a published set of city examples. So you can also use the rules in those city examples. So rules makes it very easy when you're actually modeling with Esri CityEngine. So looking at some of the other features that we have within the ArcGIS CityEngine. So the interface is quite interactive and customizable. So you can, once you apply a rule to a particular geometry, you can actually be able to see the changes on the fly. You can actually, if you apply rules to a buildings or to a street, you can actually be able to see the changes, and you can actually be able to customize the user interface. You can adjust it, you can change it. We'll be able to see that shortly. Then we have multiple views, and especially in the new Esri ArcGIS CityEngine release, that's the 2020.0 version. We now have multiple views. So if you're doing designs and you want to have multiple design alternatives, for every plan there has to be multiple scenarios so that you can be able to compare and pick the most appropriate scenario for you to be able to use. So ArcGIS CityEngine 2020 actually makes it possible to have multiple views, so you can have multiple design alternatives as you do your design. Then the other bit that I have already mentioned is the data interoperability. We can now be able to import data sets from various formats. So you can be able to import data sets if you're working with feature classes. You can import feature templates to ArcGIS CityEngine. If you're If you have your data in a file geodatabase, which is actually easier since you have all your data sets in one place, you can actually import that to ArcGIS CityEngine. And then also the CAD, the 3D industry standards, CityEngine allows you to be able to import data in the various industry 3D formats. And I think one of the things that I'd already mentioned is the CAD and BIM integration. So this is a really big plus for professionals within the built environment. Then, of course, performance-driven reporting. So with the new release of ArcGIS CityEngine, that's 2020.0, you're actually able to create dashboards and actually be able to visualize performance as you do your design scenario. So this is quite really interesting. So someone could be wondering, so what exactly can I be able to model with ArcGIS CityEngine? So first and foremost is the built environment. Urban planners play a very critical role in the built environment, among other built environment professionals. So with ArcGIS CityEngine, you can be able to model the built environment. So this includes the structures within the built environment, the utilities, the transportation network. So you can be able to model these within ArcGIS CityEngine. And the beauty with this is that we have the rules which will actually help you to be able to automatically generate these models. Then the other thing that you can be able to model with ArcGIS CityEngine is the legal environment. So the legal environment defines restrictions on land use specifically. I'm looking at a planner's point of view. So you could be having zoning districts. So within every planned area, there are different land use zones within that planned area. And for that particular planned area, there will be different zoning regulations for that particular area. So for instance, if it's a residential area, there are zoning guidelines for different residential areas. If it's a high density residential area, medium density residential area, or even a low density residential area. So you can be able to model all these within Esri CityEngine. So on the same legal environment and regulations, so there are different regulations that you'll have, say, on particular parcels of land. You can be able to model the setbacks. How much distance are we leaving from the road, for instance? How much distance are we leaving on the sides for the side setback? And then you can determine the roof types for that particular area. You can determine the floor area, ground area coverage. How much can you build on a particular parcel of land? If it's 50% or 80%, of course, this will be determined by the different land uses within a particular area. Of course, if it's a commercial area, the ground coverage will be higher. You can build maybe up to 80% of that particular area. If it's a residential area, that will be slightly different. So depending on the regulations that you have. So as you do your designs, you're actually able to implement these. And the thing with creating designs is that you're actually doing a blueprint for an actual implementation of a plan. So it's actually important to have this information within the solution that you're actually using to model. So that's just an highlight of what you're able to do with Esri CityEngine. So I'm going to take us through a brief demonstration before I can hand it over to Antony. So in my demonstration, I'm mainly going to show how you can be able to use the various rules that we have within Esri CityEngine. So let me just share my screen. So hope you can be able to see my screen. So this is ArcGIS CityEngine 2020.0, and we have quite a number of improved functionalities. One of the main things that we have in the new model of Esri CityEngine is integration with ArcGIS Urban. That's a great plus. So you can actually be able to export models that can be used directly in ArcGIS Urban. And then, so we have so this is the user interface. We have different sections. We have this section here that we call the navigator. So the navigator section allows you to organize your content. So if you have, for every project that you're doing, you'll have different information. For instance, you'll have the data, you'll have the rules, you'll have the models that you have created, you'll have the scenes, and so on and so forth. So this is the navigator section. Then this section here is the viewport. the 3D viewport. So this is where we're actually going to create our models and apply rules, and we should actually be able to see them on this model. Then we have this other section here. Once I start applying my rules, then you'll actually be able to see the details on the inspector window. So for Esri CityEngine, we have one of the main functionalities is being able to get base data for the area, for your area of study. So we have a function called get map data here. So once you go to get map data, you're able to download the base data for your study area. So for instance, maybe you're looking at having data sets for Kisumu. This is the area that Antony will be showcasing in his case study. So you're able to actually determine the extent of the area that you want to have and then download the base data. So when you download the base data, you can either choose to download the networks. So for the networks here, we're talking about mainly the road networks, and you can also be able to download the footprints as well as other shapes. So for this particular demonstration, this is gonna take some time. I have already added data to my CityEngine viewport. So I have created a folder here called webinar, and I have a folder inside it called data. So this is a section of Kisumu called Kaloleni. And I have this data actually in a file geodatabase. So notice that I mentioned about interoperability and being able to share different types of data sets. So I added the file geodatabase directly to my viewport. So we have parcels here that I want to apply rules. And then we have street networks here. So you can either import the data if you have it, or you can actually be able to create your own data sets. So for this particular demonstration, I just want to apply rules to our parcels that we have here. So I'll select the parcels that we have. And then on the inspector window, now this is the inspector window that I mentioned. So I'll simply come here and click assign rules. So I mentioned that Esri CityEngine comes with a library of rules that's in the Esri library. So you can be able to use the rules within the Esri library, or you can actually tailor your own rules. So for this particular demonstration, again, I'm just going to use the rules that are within the library. So I'm going to have rules, assuming we just want to do some extrusion for this particular area. So once I've done that, you can see on the inspector window. So once you apply the rules, the buildings are automatically generated for you. So you can be able to determine the building form. So you can be able to determine the building forms. You can be able to determine whether you want to have setbacks on these. We have quite a number of properties on the rules here. You can be able to determine the unit option, the facade textures that you're going to apply to your buildings within that particular area. So notice that for the rules I have just applied general rules. So you can determine whether this is going to be the use for these buildings is gonna be a residential use or industrial or commercial use. So you can determine what exactly you want to use. So just allow me to undo that so that I apply another rule file. So if you're not, maybe if you want to change the rule file, you can undo and actually apply another rule. Then I have a section here that I have just digitized for the sake of this presentation, the street network. So I'm gonna select it. And I want to apply rules to this particular section. So I'll simply come here and assign rules. Then again, I'll go to my rule folder. For this particular one, I want this specific type of rule. So I'm going to pick the street construction rules. Let me just do that again. So I'll apply rules to that particular street. Let me just zoom in so that you can be able to see. So again, you can be able to choose whether you want to have, for this one, I just have the general texture enabled. So you can be able to refine it further and further depending on what exactly you want. And then on the road layout, you can decide to have maybe traffic on one side of the road or on both sides of the road. So there are quite a number of properties that you can be able to change. If you want to have biking lanes, you can do that. You can determine the parking layout on your roads. You can decide to have vegetation within your roads. So maybe let me just enable vegetation. So then I can determine the type of vegetation that I want. Maybe I just want standard grasslands within that particular area. Then I can determine the width. Then you can also choose whether you want to have street objects. If you want to have traffic lights, you can enable that. If you want to have the percentages of the crops on your streets, you can also enable that. Sorry, I think something ain't. Let me just undo the same. Let's reassign that again. Back to my rules. So you can be able to change the properties depending on what exactly you want. So rules make it actually very, very easy for you to be able to generate your 3D models. So once you're done with creating your model, then you can actually be able to export the model and publish it to ArcGIS Online. So this particular demonstration, I just wanted to show you how you're able to use the rules within CityEngine to be able to generate models of your area of interest. So in the case study, we're going to look at some of the models that have been done with ArcGIS CityEngine. So I'm going to hand over to Antony to just take us through a case study that has been done in transforming urban planning and design with ArcGIS CityEngine. Over to you, Antony.
Yeah, thank you very much, Evelyn, for the interesting presentation. So interestingly, what we'll find out that CityEngine is very, very significant in our current times for us to advance our urban planning. So it provides the unmatched capability of not only bringing life to the plans that we make as urban planners, but it also provides you the opportunity to teleport into the desired future and also travel back in time, of course, to pitch to our government and also to our people, why do we need the plans, and also how can we solve them, and also some of the resources that have to be sacrificed so that we can catapult our communities into the future that we've foreseen using the CityEngine. So today I'll be making a presentation using an ArcGIS story map. So I'll be more telling a story about a geodesign process or research project that we did in Kisumu. So it was conducted in an informal settlement in Kisumu that is within the slum belt. It's called Manyatta Informal Settlement. So the study was conducted in 2019, 2020 up to around March. So the research itself is hinged on a participatory action research approach, whereby it involves a series of community participation. So the station itself, it accommodated the young men and women, and also the old, from all the subunits, the 9 subunits of Manyatta Informal Settlement, whereby they convened for a common purpose that was to, first of all, map their problems, and then also to go ahead an extra mile to sketch the future they want for themselves and also their children. So we also went further and even exposed them to geographic information system, and we gave them the steering wheel to make decisions about the prescriptions of the CityEngine. So guys, just buckle up your belt because I'm going to take you through a wild ride. Yeah, so this is basically Kisumu, the inland port at the Lake Victoria region. So This also shows the confines of the county, Kisumu County. So it has around 35 market centers and towns. With the circle one, this the inland port city, where we are having the slum belt just after you crossing the international highway that goes all the way from Busia. That's where you find various informal settlements like Manyatta, Obunga, coming sprout. So we'll go straight to Manyatta settlement. So this is the map of Manyatta Informal Settlement. So I have an illustration of having 1 and 2. So for 1, it shows the Manyatta A and B. So these are different kind of regions. So why is it is a region? Is that for Manyatta A that represented in 1, you find that it is highly dense in terms of the settlements that are there. Another thing is that it's more of a concrete jungle, whereby the vegetation there is very, very scarce as compared to Manyatta B that has the rural characteristics, whereby you find that people even continue, people still practicing livestock keeping and also farming. So we have different villages, Manyatta A and B. So in Manyatta A, you'll find villages such as Kondele, Flamingo, Gonda, Magadi, Konambuta, and Metameta, and also Manyatta B. So Manyatta B, like I said, it has some sort of rural characteristics, whereby it is interspersed by natural features like the rivers, and also there's also farming going on. So this is just a map of the different villages that we have in the whole of Manyatta, both Manyatta A and B. And then the existing situation. Currently, some of the major problems that are glaring to the community are some of them were informal housing, dilapidated access to the roads, and also poor waste management. So this one infringes into their public safety in terms of security, and also there's also poor access. At certain times, whereby when you cross there beyond 6 p.m., you cannot move because you are scared about issues of mugging. So we also went ahead and mapped with the community the existing facilities, the existing land use that is in Manyatta, is Manyatta A and B. And we found that almost 80% is covered by residential. So the inadequate social amenities, most of the social amenities are sourced from outside. So there is a lot of traveling that comes from the informal settlements, going outside, sourcing services such as health services, educational services. Most of them are outside the informal settlement. So we wanted to change the narrative, and we sat down with the communities, and we did a community participation session whereby they mapped their problems, and also we also told them to sketch the desired features that we want. So this is a prototype of Kondele. So this how Kondele looks like. Actually, here it is. Actually, it's at this level. Actually, here it is. At the far end corner where we're having the roundabout that goes over to Busia. So here it is. So I was able to just zoom into the Kondele village or the subunit. This won't currently exist. As you can see, we're having almost 85% going to residential. And we're only having educational facilities, a nursery school. We also have private health center. There's no public. Those we have a church. So the rest are only covered by commercial and residential. So we started with the community and we did a design. And actually, this was the preferred design. As you'll note, we've added more access as opposed to what we're having right now. So we added more access into it. We also added the recreational. As you'll note, there's no recreational. We went further and added that. We also solved the problem of poor waste management, whereby we stationed different waste collection points. And also we tried also to maintain the commercial corridor, especially when you're from the roundabout of going towards Kibos. So that's a very significant commercial corridor that we decided to maintain. And also there's also a market next to the roundabout, and this one often causes conflicts of movement and also accessibility at that junction. So the community themselves, they emphasize the relocation of it, and we replaced it with a park or public square. So we shifted the market where it's painted purple, just next to Konalejo. So we also provided a park for it, because many times we find that our vehicles, or the vehicles that are bringing goods to the market, they often park along the road, and that also causes conflict to the pedestrians. So we provided a park for the lorries. So this is basically the process that entails. So first of all, we had just to map what currently exists. Then we sat down to do the geodesign, whereby we did proposals. We did different kind of design, alternative designs, like the transit-oriented models, the mixed-use models, and also integrated models. And we sat down with the committee, and they chose the one that they wanted. So we also went further and did the geodesign, and also we stepped it up a notch to add up the aspects of CityEngine, so that they could define the kind of houses that they want, the kind of environment that they want. So we have a series of structures that we used or inculcated in the designs. This was significant in helping us do the design. So some of the structural elements that we used were existing developments, the road networks, especially the roads that were currently existing, that have been delineated by the surveys of Kenya, and the Kenya Rural Roads Authority, and also the Kenya Urban Roads Authority, just to maintain them. Also, we have riparian reserves. We had River Uji and Kothon River passing through the informal settlement, going all through to Nyalenda. And then also another defining characteristics of the two regions is that when you go to Manyatta A, the soil is more stable. Now when you go to Manyatta B, it is constituted by poor clay soils. So that one affected most of their buildings that they built. Many of them during the survey, they're complaining that most of their houses were collapsing. They wanted the government to do that. And actually, if you go to Manyatta B, currently there's this road that is being constructed in Manyatta B, and it is facing problems because of the poor clay soils. So we had different multiple development models that we used in doing the geodesign. So first of all, we had the zero model, this minimalistic approach, whereby we're trying to maintain the status quo and we're not doing anything. Actually, that's very disastrous, because we'll eventually have a worse situation if we don't do anything about the informal settlement. And then we also explored the transport-oriented model, whereby its major priorities on the transport corridors. And as you can see this map, we find that during our mapping stages, we find that there are various commercial engines within the Manyatta Informal Settlements. Those are the commercial nodes that you'll find their market centers over there. So we decided that we're going to maintain it, because if you do different kind of proposals, for example, residential, then you'll be killing the lives of the commercial prosperity along those regions. So we try to maintain some, like this one is Konambuta, this is Kusau, and upper here is Konalejo. So, and also in Manyatta B, you should realize this a major market center that's down there. It's called Kasawino. So we tried also to maintain that. So the transport-oriented model is just focusing on those developments that mostly survive, or they thrive best when they're located next to the transport corridors. Then we also explore the mixed-use model, where in the mixed-use model, we try to present the option whereby we bring life into the villages. Like what I did present initially for Kondele, we only had residential and commercial, and a few of the educational and also the health facilities. But now in this case, we are reviving it by bringing vibrancy, by introducing recreational facilities, by introducing public facilities like library, where it's able to reduce the kind of distance that the communities are able to walk just to access the services. So when you did the mixed use model, you find that every village was being represented by the by the mixed-use model. And then finally, we did an integrated model whereby we brought both the mixed-use model, the transport-oriented model. This was the final result, whereby we pick the positive aspects of the transport-oriented model, and the mixed-use model. You harmonize them, and you have the final result. So there are different land use zones. And this one was very significant in us preparing the structure plan. So we were inspired and were guided by the physical planning handbook, whereby it gives, it presents to us a different kind of land uses that are there in terms of when you're preparing the plans. We have residential, we have industrial, educational, recreational, public purpose, commercial, and public utility, and also transportation. So this was very significant in us doing a spatial analysis to identify within every village what is the bare minimum in terms of facility, what is the bare minimum vis-a-vis the available population. And also we did our projection. So for example, after 20 years, what will be the situation vis-a-vis the current social amenities that we do have. We also put into place the inadequacy in terms of the space. So we need to plan ahead, make sure that we're only not making a plan for the next 3 years, but we're making a plan for the next 20 years. So we made a detailed plan. Actually, there's a lot of correction out of here, but finally we did it. We were making changes all over there, and the community participation session helped a lot in this. So we were proud enough just to prepare a plan. And actually, this is a success story for the Institute of Conscious Global Change, because as of now, there's no plan. There's no plan for Manyatta. So that was a success story. And actually, that's even informed the Kisumu City Planning Department, because currently they are marching into preparing the development plans for all the informal settlements for Kisumu City. So that will be very informative for them. So we translated it to the extra level, whereby we went further and did the subunit designs. So we broke it down into various units. So we had 9 subunits. So in this case, I'm calling them urban villages, based on the different defining character of the regions. So number 1, we have Kondele. So this is the spatial design of Kondele. So after we did the design for Kondele, the community themselves, they felt that well and good. They make plans and they submitted to the county department guys, and what is being implemented is not what they envision. So we had a very motivated session whereby they went further and we did the designs in terms of them commanding the kind of designs of the buildings that they want, the kind of roads that they want, the kind of infrastructures that they do want. So the next session is because every design is attached with the 3D design of the settlement. So I'll just shift it. Just to save on time, I'll just shift it to the real, because of time, I'll just shift it to the real designs of the villages. Yeah, so this flamingo, so this one of the villages, so this flamingo. So we sat down and did the designs. And actually Kisumu, they are very, very ahead in technology. So they did the design in terms of the buildings that they want, and also the environment that they do want. The bigger problem also, they now brought the issues whereby we're having a closed community where people having gates. So they were looking to the aspect where it is an open place, and the street design also will help in terms of improving accessibility and also restoring safety and also the dignity, and also to protect the cultural attachment of the communities. So we did the designs of educational facilities. We did almost all, and actually all of the land uses. So this is how Manyatta looks like in terms of 3D. I was prepared by the community. So you note I've removed some options. I've removed some infrastructure such as the street planting, and also the stormwater drainage, because they're so heavy. I could not just load it up. But what we wanted is just the bare minimum, so that when you open this ArcGIS story map, even the person that is the lower level at Manyatta Informal Settlement can open this ArcGIS story map and be able to see the designs that have been prepared. So this was Flamingo. So I'll just shift again and open another village. Yeah, so this is Gonda. So this is Gonda village. So after we did the spatial designs, we also went ahead and also did the 3D design. And the villagers, the community were very, very significant in terms of defining the kind of buildings that they want, in terms of the height. And also, we also incorporated the planning consideration for the zonings, especially for the zoning, the setbacks and also the building lines that are significant for the different land uses. So we picked that from the county and we did the design. So when we were doing the design, it was very, very informative, because we had both what the government wants vis-a-vis what the people want. So we are able to integrate that. So yeah, so back to my presentation. Yeah, so what I did was I just opened the web scenes, external web scenes, just to save on time, because some of them are pretty much heavy, but you cannot open them as of now because of time. So this was Kondele. The next one was Flamingo. So we had a spatial design accompanied by the 3D designs. We also had the Gonda subunit design, also accompanied by the 3D design. It will take time. That's the problem I was evading. We also have Magadi, also did the design and also the 3D designs. Also Kolambutra. So there are 9 villages that we did. Yeah, and finally, it was a series of sessions, and finally, we finished our GeoDesign process, and currently, I think we are published. So basically, the CityEngine, it is very, very significant in our current times to outsmart the dark waves of urbanization. And actually, urbanization is coming. And actually, as urban planners, we have to guide our cities so that we can restore sanity. We don't have to have problems of informal settlements and the slums. So it's also very significant because it becomes an accountability partner for our governments and also our contractors during the slab upgrading process, to ensure that every drop of the taxpayers' money is spent appropriately in realizing the community dreams. So I was just looking into Singapore, and good enough, Singapore has done it. So Singapore has done it and has something to show for it. So why can't we do it? So I think the ArcGIS story map will be shared after the presentation by the S3 team. Actually, that's Etta Jackson that did the research work. So over to you, Evelyn. So I think I'm done.